Welcome to Finite Automata to Regular Expression Conversion. This is Dr. Teo Kim Hing, Informatics Academy. The question considered in this talk is as follows. Assuming that we have a deterministic finite state automata M, how to find a regular expression E such that the language of the regular expression is the same as the language recognized by the machine M. There are many methods to construct a regular expression which is equivalent to a given finite automata. This tutorial explains the state removal method which is used by JFLAP. The state removal method is based on the transformation from non-deterministic finite automata to generalized non-deterministic finite automata. There are 5 steps in the method. First, make sure that there is a single non-initial finite state. Second, convert multiple transitions between two states into a single transition using regular expression with plus operator. Ensure that there are transitions between two states. If there are no transition between two states, we add empty transition corresponding to empty set, which essentially means no transition at all. Remove non-initial and non-final states one by one and change the transition accordingly. Finally, we have 2 states, one initial state and one final state. Get the resulting regular expression from the 2 state in the generalized finite automaton. We will use a very simple finite state automaton with 1 initial state Q0 and 2 final state Q1 and Q2. Once you design the finite state automata, you can click convert and choose convert finite automata to regular expression. The tool provides by the conversion are attribute editor, state editor, transition editor, transition collapser, state collapser, and so on and so forth. When you first click convert finite state to automata, if the automaton has 2 final state or the final state overlap with the initial state, you will get this message: make single non-nominal final state. How to do it? We will create using the state editor, create a new state, and then add lambda move from the 2 final state to the new state. So when you use the state editor, we create a new final state, and then we add lambda move from Q1 and Q2 to Q3. If you have multiple transition, for example, from Q0 to Q0, we got transition A, B and lambda. We can use the transition collapser tool to turn multiple transition to one single transition that involve regular expression with the addition operator. This is the transition collapser tool. The method requires that there is a transition between any pair of states. Since we got 4 states in the finite state automata, we should have 4 times 4 equivalent to 16 transition. So we can add transition using the transition editor and add empty transition. Empty transition are labeled with empty state. Note that this is different from the transition with empty string, lambda. Empty state transition means no transition. The transition will be blocked. Now we are ready to go into the most important step, in which we remove non-initial and non-final state one by one. For example, we got Q1 and Q2, which are not initial and not final state. We will remove it one by one. We can use the state collapse tool. When you click the state collapse tool and choose Q1, it will have a transition window show the transition window lists all the transition with label that will be present in the current graph if the state Q1 is going to remove. For example, between Q0 to Q3, the level is CC star. What happened is, from Q0 to Q3, there are 2 paths. One is going through Q1. So Q0, Q1, Q3. This path level should be C star, and lambda. Another path from Q0 to Q3 directly, the level is empty set. When Q1 is removed, the path level will added to the original level, empty set. So CC star lambda added to empty sets can be simplified to just CC star, as what you see here. You can click final line. The tool is so powerful and it will help us remove Q1. After remove the state Q1 and Q2, we have only 2 states left. The initial state Q0 and final state Q3. It will be quite straightforward to read the regular expression from the final generalized transition graph. For example, from Q0 to Q0, we got A plus B plus lambda, which gives us the loop A plus B plus lambda star. From Q0 to Q3, we got CC star plus D. And from Q3 to Q3, we got empty string, empty set star. Empty set star actually is lambda. So when you click export, it will give us the final result A plus B plus lambda star concat CC star plus D. Of course, this can be simplify to A plus B star CC star plus D. We look at the second case study. It consists of only two states, Q0 and Q1. Unfortunately, Q0 is the initial state, it's also the final state. We need to separate the initial state and final state. So what we do is create a new final state Q2 and make a lambda move from Q0 to Q2. And Q0 is no longer a final state. In this way, we separate initial state and final state. Then we add all the transition, and then we remove non-initial and non-final state Q1. We left with Q0, Q2, and then we can read the final regular expression. In this case, AB star lambda empty set star, which is also lambda. So AB star lambda lambda is AB star. This is the end of the tutorial. Thank you for your participation.